Hello everyone, my name is Abdallah Dwikat. I am last year computer engineering student at Istanbul University, and today I'm presenting our joint paper about comparing model results for predicting temporal variations of SST, sea surface temperature, and rainfall rate. In the beginning, the first question that should come to your mind is, why is it important to study the sea surface temperature? So actually the oceans and the water represents 71% of the globe, which is basically regulates the air temperature around us firstly, and it affects the climate change in many cases in which the oceans, actually we can say that it is a carbon sink that firstly produces at least 50% of the oxygen that we breathe, and additionally it absorbs 25 to 30% of the CO2 emissions around us. And the warmer the water, the more space it takes up and the lower its density. What does that mean exactly? So whenever we have more warmer water, warmer sea surface temperature, so we have higher sea level rise, it impacts the marine life as well. The stratification, it means that the lower density stays at surface and the lesser exchange with deep water. This exchange that happens between the sea surface temperature and the cold deep water, which is very important for our climate change. Whenever we have warmer sea surface temperature, this exchange is lesser and lesser. The study area of our research paper was in two cities which focused on the eastern and the western part of the Mediterranean Sea in Turkey, southern Turkey, which is in Antalya city and in Adana city, and that could allow us to compare how is the difference between sea surface temperature in the eastern and in the western part of the Mediterranean Sea. So the project methodology aligned with firstly the data collection from different resources, the data cleaning and pre-processing, such as the missing data parts, the dates for each city, the exploratory data analysis, which we could have analyzed the sea surface temperature and other atmospheric features as well. Modeling, which is the machine learning or time series machine learning modeling to forecast sea surface temperature for future, and in the end the results. As we can see the correlation matrix heat map, we can see the sea surface temperature in the red array, and the other cross correlation with the sea surface temperature, which is very important to understand for the climate change effects. We can see very strong correlation between sea surface temperature and the average air temperature, for example, and also the dew point value, and with pressure in a minus correlation. However, also even if we don't have a strong correlation, sometimes with model building, it is really important to use most of the features, let me say, to build the model. General analysis, we can see here the trends for the sea surface temperature at the left side in Antalya city and at the right side in Adana city, which we can see, for example, warmer trends starting from the 2018 and so on, in both cities actually, in Adana and in Antalya. So here we can see the sea surface temperature for Antalya city. We can see that August is the warmest usually in the year, and March is the coldest in the year also. And we can see the seasonality analysis in the right part. We can see, of course, the summer and is the highest or the warmest, and winter or sometimes even spring is colder in some cases. Here we can see more specific analysis for the sea surface temperature. We can see also the warmest in August, also in specific months, such as in the 2010 in August, 2023 as well. We can see also in the right part the precipitation or the rainfall rate in Antalya city as well. We can see in January 2019, in which there is a flood in the city of Antalya. Here is the machine learning modeling part, in which we focused on the two cities building two different models in each city. In Antalya, we built the LSTM, long short-term memory or deep learning, linear regression, and decision tree. In Adana, we built the XGBoost, random forest, AdaBoost, and SVM, support vector machine. Starting from the linear regression, we can see in the left part the correlation between the sea surface temperature and itself in the previous year. And that is important for understanding the difference between one year and the other, which is usually warmer in the next year due to many features, due to climate change effects as well. And this comparative between the year and the other, the previous year and the other, is very important to understand this difference and to understand what is the thing that is making this difference for the sea surface temperature to going warmer over and over in the year and the other. Here we can see the feature engineering part, in which we could add some other features during building the model, during the decision tree building the model, in which we added the year, the month, the day of year, in which those features could help the model to more understand, to forecast the sea surface temperature. We can see up without those variables or without those features, and down after adding the features, in which the model was more relevant with understanding those time features. Here is the sea surface temperature results with LSTM. We can see it's 98%, and which we built the sequence-to-sequence modeling with one encoder layer and one decoder layer, and also in random forest model, which the test set aligns for the last 3 years, starting from the 2021 until the end of 2023, for both models. For future work, I would like to describe a small part we started in, which is the early warning system. The early warning system is very important with our modeling, in which we can use those forecasts for future modeling and build a machine learning classification model, and that needs a very big data collection. That can align by adding the storm, for example, or the flashing, lightning data as a target, our target, and the input of our model would be those models that we have built in this research paper, and we can understand what is the correlation and what is affecting the storms and what is affecting the warning system, the disaster management cases with those features, atmospheric features around us. We can see in the left part, for example, more than 80% of cross-correlation between the storm or the lightning classification and the total precipitation in around the city of Bodrum. And even though, for example, the least cross-correlation with the event is probably the air temperature, but we can see in the left part, in the bottom, the air temperature affected the most, the Gini important during the gradient boosting classification model. So even if we don't have this strong cross-correlation between the features, it is still important to continue collecting the data in which it affects building the model. The benefits of our study aligns with the United Nations Strategic Development Goals, the life on land, the life below water, climate change, clean water and sanitation. And let me tell you, dear colleagues, that we have two main indications, positive indications with that there are indications of citizens who really do care about the climate change, which aligns with partnerships for the goals. And also we have the key solution, the key factors, that all the development, all the technology around us to use clean energy, and the technology that we have today in 2024, but the use of this technology can help us to have a clean and a more healthy and secure future. So, dear colleagues, I would like to say that it is possible to build this more clean and more healthy future, more secure future, and we all win if we succeed. In the acknowledgement part, I would like to thank the NATO, North Atlantic Treaty Organization's SPS, Science for Peace and Security program for supporting us during this project. And a special thanks for our professor, Professor Dr. Zafar Aslan, monitoring and guiding us through the project, and special thanks for my colleagues in Istanbul University. Thank you so much for listening.